Okay, folks, we're going to do some algebraic properties of limits today. This says each of the properties of limits can be described in words and also in mathematical notation. It's your job to write each sentence below in mathematical notation. Well, okay, let's give this a try. Property 1. The limit of a constant is that constant. Interesting. The limit of a constant. Well, let's see here. The limit of a constant. Let's just say that x is approaching, I guess x can approach anything then. So if x approaches some number, a, and we go to plug in a for x, well, there is no x. All right? So it's just going to be that constant. The limit of a constant is just that same number. Okay. So if this said the limit as x approaches 10 of 5 equals, well, that would just have to equal 5 because the line y equals 5 is just always at 5. So even if you go out to x equals 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the horizontal line at 5 is still 5. Okay? I hope that makes sense. So property 2, the limit of x as x approaches c is c. Whoa, okay. The limit of x as x approaches c is c. The limit of x as x approaches c is c. Okay, well, let's consider that. Well, the line y equals x is this line here. And if x is approaching, let's say 10, wouldn't we get 10? So if you start thinking about some of these properties and just putting a number in, oops, we'll call that x there, and I put that 10 right there, I would get 10. All right, so some of these properties are really useful. Some of these properties just pop up a bunch, and you'll just know how to use them. But those are two that it's a little bit harder to write these, to think about how to write these, huh? All right, so let's look at property 3. The limit of a constant times a function. You know what? Let's call this function f of x. Let's do that. And let's call the constant, let's call it c. So I think I'm going to have c times fx. So the limit of a constant times a function is equal to the constant times the limit of the function. What? Okay, so let's say x is approaching some value a. So the limit of a constant times the function is equal to the constant. All right, so I need to take the constant out, constant times the limit as x approaches a of the function. Okay. The hard part about these, about turning this stuff into mathematical notation, is that this doesn't say the limit of a constant times a function as x approaches a. Okay, so I just had to make this little part up right in here. So that's kind of the hard part, is understanding where that's coming from. Okay, so here we go. The limit of a sum or difference is equal to the sum of the limits. Okay, so the limit of a sum, the limit of a sum, let's just do something like we're going to add two functions together. Let's just do f of x plus g of x. And let's make x approach to a. So what this is saying is that the limit of a sum is going to be the sum of the limits. So if I just took the limit of f of x and I added the limit of g of x, then that would be the same exact thing. I'm so sorry that I don't have enough room there. Ran out of room, that's what I was trying to say. Okay, let's get my camera straight. And then it says, or you could do this using a difference. So I'm going to put this in a different color. It's not too different of a rule. But the limit as x approaches a of f of x minus g of x. And perhaps that'd be helpful if I had the parentheses there too. Okay, so we're going to say that is the same thing as the limit as x approaches a of f of x minus the limit as x approaches a of g of x. Okay? So, helpful. So here's another one dealing with products. But this says the limit of a product. Well, what are we going to multiply together this time? Well, let's just use that f and g like we did last time. So we're going to say the limit of f of x times g of x, the limit of that product, we're going to say that x is approaching some value a, is the product of the limits. Well, that means I need a limit over here. And then I need a limit over here. So a limit of the products, limit of this product, maybe we could put that in brackets. Limit of a product is the product of two limits. All right. Property 6. The limit of a quotient is equal to the quotient of the limits. So this looks a lot like the previous question, except for, or the previous property, except for we're going to use a division symbol. So the limit as x approaches a, and you know what, let's use math type. Let's use a math type division symbol just like this. And that's going to equal the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. So that just says the limit of a quotient, this is our quotient here, the limit of that quotient is equal to the quotient of two limits. All right, property 7. The limit of a composition is the composition of the limits. Well, what is a composition? Well, remember that's when you substitute one function into another function. So let's do f of g of x. Okay? And it says provided that f is continuous at c. Well, we might have to change this if we're using f of g of x, right? So let's look at that. The limit of f of g of x as x approaches a, the limit of a composition is the composition of the limits. So what does that mean? What that means is that we're going to take f, I dropped my pen, I'm sorry. We're going to take f and f of, we're going to take the limit of the inside function. All right, that's exactly what that means. So basically, what you can do is take this a, put it right there, find out what that number is, and then just do f of that number. Now it does say provided that f is continuous, so basically, well, f has to be defined then, doesn't it? It seems like g has to be continuous as well, because you're going to have to find a limit first. We'll have to think more about that and see if we run into any trouble with that one. But that's a good property there. And then the squeeze theorem. If the values of a function lie between two values of two functions with the same limit at c, then that function must share that limit. You know what? We're going to hold off on this squeeze theorem thing, and I'm going to make just a lesson for the squeeze theorem. But let's go ahead and put it in mathematical notation. Okay? Okay, so suppose we have three functions. So let's just say something like this. If f of x is less than or equal to g of x is less than or equal to h of x. So we just took care of the first part. If the values of a function, g, lie between the two values of functions, and these functions, h and g, the limit as x approaches a of f of x is equal to the limit as x approaches a of h of x. Let's just say they're both equal to some limit. I'm going to write capital L. Then that function g must have that limit. Okay, then g of x, then the limit as x approaches a of g of x also equals capital L. All right, and so again, that one is probably the absolute hardest, next to maybe the composition one, to kind of tackle. So anyway, that video, my friends, is supposed to tell you all about algebraic properties of limits. Now, unfortunately, it doesn't give you much practice, so you'll be working on exercises outside of classroom to try and figure out what these algebraic properties actually mean in terms of how to solve problems. I hope that you enjoyed this, and I hope it's helpful in your mathematics endeavors. We'll see you in another video.